Hello everyone, you are welcome to Mathematics Tour. This is IGCSE Mathematics Paper 4, Component 4.1, written in November 2023. If you are seeing this channel for the first time, please kindly subscribe to my channel by clicking the subscribe button. Hit the notification bell to receive notification anytime I upload a new video. Also, like, comment and share this video. There are 11 questions in this paper and I will solve them at once. So let's jump into the first question. Question 1. Describe fully the single transformation that maps shape A onto shape B. So let's look at shape A. This is shape A and you want to see the transformation that maps it onto shape B. So this is shape B here. So if you notice, let's label it first. You have A here. Okay, let's use another letter. We have point P, you have point Q, and we have point R here. So if you look at this one, this will be P prime, and this will be Q prime, and this will be R prime here. Okay, so if you look at it, let's count from P to P prime and see the distance there. So you have 1, 2, 3, 4, 5, 6, 7. Okay, so and it comes down once. Okay, so that means we have translation. So we can write here. So translation. Then by what? By the vector 7 minus 7 rather minus 1. Okay, because we counted towards the left hand side, that is -7. Then we counted once downward, so that would be -1. So that means x equals to -7 and y equals to -1. So that is the translation. So for the name of the transformation, you have 1 point, and then for giving the direction, so you also have, by giving the coordinate, you have 1 mark as well. Okay, so let's go to the next question. Shape A onto shape C. So this is shape A onto shape C. So if you look at this very well, so this is rotation. Okay, so let's try to get the corresponding points. So it's like it was turned like this. Okay, so that is what I can see clockwise there. So if you follow that, okay, so we're going to have point P to be this side now. So it will be P prime prime. Then point Q will be here. So it will be Q prime prime. And then point R will be here. That will be R prime prime. So and it was rotated towards this direction. Okay, so that is how I got to know that it is rotation. So but we need to we've gotten the name, that is rotation. We need to get center of rotation, and we need to get the direction, the degree and the direction of the rotation. Okay, so to do this, the first thing we need to do is to get the center of rotation. So to get center of rotation, so you have to join two corresponding points together and bisect them. You look for another pair, that is another corresponding point. You join them together and you bisect them as well. So where the perpendicular bisector of the two lines meet is the center of rotation. So in this case, I'm going to join point Q and Q prime prime together and bisect. I will also join point P and P prime prime together and bisect. Let's join Q and Q prime together. Then we also join P and P prime prime together. So I will bisect the two lines and show you the results. I have drawn the perpendicular bisectors of the two lines and they meet at this point here. X equals to 5 and y equals to 1. This is the center of rotation. So to get the angle, so what we need to do is to draw a line from the center of rotation to a point on shape A, and draw from the center of rotation again to the corresponding point on shape C. So let's draw a line from the center of rotation to point Q, and from the center of rotation to point Q prime prime. So from the center of rotation, let's draw a line like this to point Q. Then we draw another line from the center of rotation to point Q prime prime. So it is obvious here that this is 90 degrees. Okay, it's obvious, but you can still check. So you take a protractor, center of the protractor on center of rotation, you set it very well. Then you put 0 here on point Q. Okay, so you see that it moves from point Q towards this direction and up to 90 degrees. So that is 90 degrees clockwise. Okay, so if you want to test with other points, so it can be P and P prime prime, you see that you still have a right angle. Okay, so and me looking at this is perpendicular to this, so it is 90 degrees, but you can always use your protractor just like I've shown you to check the angle. Okay, so now I have all the criteria now, so I can now go down and write the necessary and give the necessary information. Okay, so shape A onto shape C is rotation. Okay, so center is 5,1 and it is 90 degrees clockwise, and you could write 270 degrees anti-clockwise, so they are the same. So let's go to the next question. On the grid, draw the image of shape A at a reflection in the line y equals to 2. So let's go to where y is equals to 2 and draw a line there. So y is equals to 2 here, so you can draw a line like this, y equals to 2. Okay, so this is the line y equals to 2, so don't mind the ellipses here, so it's due to how the question was scanned. So that is why it does not fit in on that grid. Okay, so this is y equals to 2, so we need to reflect shape A, okay, on that mirror line. Okay, so this is shape A, you have it here. So let's count P, let's count from point P to the line. So you have 1 2 3 4, so we'll continue in that direction. 1 2 3 4, so this will be a point here, so this will be P prime 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 now. So let's check that again, so let's remove this, so let's check that again. You have from here 1 2 3 4, so we counted 4 from point P to the mirror line, so we need to count 4 upward from there. 1 2 3 4, so that's okay. So let's go to point Q, so 1 2 3 4, 1 2 3 4, obviously it should be here, so this will be Q prime prime prime, and the last one is point R. 1 2 3 4 5 6, so count 1 2 3 4 5, so we need to go up a little bit, so to be 4 5 and 6, so this will be R prime prime prime. So the next thing we need to do is to connect the 3 points together from P prime prime prime. So we draw a line to R prime prime prime, then from here we connect this to this, and finally we connect these two, so this, so that will be the reflection of shape A. So at the line y equals to 2. The next question is shape A after an enlargement, scale factor of -2, center 0, 0. So this is the center of enlargement, and then the scale factor is -2. Okay, so that means we want to enlarge shape A. So to do the enlargement, we count from the center of enlargement to each of the points on shape A, then we multiply by -2, and that will give us the corresponding point of the enlargement, that is the image. Okay, so let's count for P. So from the origin, let's count to point P. So you have 1, 2, that is x equals to 2. I can write it here, x equals to 2. So then you count from there 1, 2. So y is equals to -2. So if we multiply by the scale factor, which is -2, so we are going to have -4 and 4. So that will be the image of the point, okay, of the enlargement. So from the center of enlargement, so let's count -4, it will be here, and let's count 4, so it will be here. So this will be point P prime 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 prime, I think 4 times. Okay, so from center of enlargement again, so let's count to point Q. That will be 1, 2, 3. Then you have I can write it here, you have 3. Then you count downward 1, 2, that will be -2. So if you multiply by the scale factor -2, so that means the image will be at -6 and 4. So if you have -6 will be here, then +4 will be up here. So we have the point here. So this will be Q prime 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 and prime, and the last one will be point R. So let's count from the center of enlargement. That will be 1, 2, 3. So x equals to 3, 1, 2, 3, 4, and y equals to -4. So 3, -4. So if you multiply by the scale factor, which is -2, so we're going to have -6 and 8. So x equals to -6, then we need to go up to 8, and this will be here, 8 is here. So this will be R prime 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 prime. So this will be the enlargement. So we can now connect the point together. So let's start from here. So this and this, you connect them together. Then this and this, you connect them together. Then finally this and this, you connect them together. So this is the enlargement of shape A. So let's go to the next question. So question 2, find the value of x when A is equals to 9.8 and t is equals to 20. So let's key in the values. S to be equals to half into bracket 9.8, then into bracket 20 squared. So this will give us a half into 9.8 into 400. So you could have, so 2 goes in 2 once, 2 goes in 400, that is 200 times, and we have 9.8 times 200 left, which is same thing as 9.8 times 100 times 2. So this will give us 980 times 2, and finally this will give us 1960, that is 1960. Question 2b. So solve this. We need to expand the bracket. This will give us 20y subtract 15 equals to 15. So if we collect like times, we have 20y to be equals to 15 add 15. We have 20y to be equals to 30. If you divide both sides by 20, so we have y to be equals to 30 out of 20, and you have 3 over 2 as 0 cancel 0, so which is same thing as 1 whole 1 out of 2. So 1 whole 1 out of 2. So the next one, expand and simplify. So we need to expand this. We have 15x minus 24, then minus 6x, then plus 14. So now we need to collect like terms. So we have 15x, then minus 6x, then we have minus 24, add 14. So if you do this, we are going to have negative x, then minus 24 plus 14, that will give you minus 10. So that means we have minus x minus 10, okay, which you can write as minus open bracket x plus 10. Okay, so we can write minus x minus 10, or you write minus into bracket x plus 10. So that will be the simplification. So the next one is to rearrange, that is this 2d. We have a equals to 2b squared minus 3c cubed. So to make c the subject, minus 3c cubed, we transfer it to the other side. Okay, so the left hand side, that will become positive. We have 3c cubed, then equals to, by the right hand side we have 2b squared. Then we can now bring in a to the right hand side, that will be minus a. And finally we divide both sides by 3. Okay, you have this, so this will cancel this. We are left with c cubed to be equals to 2b squared minus a everything over 3. And lastly we take cube root of both sides. So cube root of this, cube root of this, so cube we cancel cube root, so we are left with c to be equals to, so sorry, cube root here, so we have cube roots of 2b squared minus a all over 3. Hence c is equals to cube root of 2b squared minus a over 3. So let's go to the next question. We are to factorize 6p cubed minus 4q minus 3p plus 2. So in this case we can take 2, we can factor out 2q, then we are left with 3p minus 2 here. Then from here we have minus 1 to be common to minus 3p and then 2. So we have minus 1 then into 3p minus 2. So we can now take this 2q minus 1 then into 3p minus 2. So that is the complete factorization of this expression. So that means we have 2q minus 1 into 3p minus 2. So let's go to the next question. That will be question 3. The table shows information about some of the planets in the solar system. Roman figure 1. The average distance of Mars from the Sun is 2.279 times 10 to the power of 8 kilometers. Write this distance as ordinary number. Okay, so you just have to write the standard form number, which is this 2.279. You write it out, 2.279. Then we start from the decimal point and move forward 8 times. Okay, so that will be 1, 2, 3, 4, 5, 6, 7, and 8. So the decimal point is now here. So we fill up this with zeros, and the answer will now be 2, 2, 7, 9. Then how many zeros? 1, 2, 3, 4, 5. 5 zeros. So that will be 1, 2, 3, 1, 2, 3, that is 227,900,000. Roman figure 2. The planet Uranus has a diameter that is 35.8% of the diameter of Jupiter. calculate the diameter of Uranus. So we can get our answer from this sentence, that is, the distance of Uranus is 35.8% of that of Jupiter, okay, the diameter of Jupiter. So we can say, okay, the distance of Uranus, let's say U, will be equals to 35.8%, that is over 100, then multiply by the diameter of Jupiter. So if you scroll up, this is the diameter of Jupiter here, 143,000. So you have 143,000. So you can make use of your calculator and you get your answer straight away, and that will be 51,194 kilometers. And alternatively, you can use this. You can say 100%, okay, will be equals to 143,000. Then 35.8% will be what? Will be x. Okay, so if you cross multiply and solve for x, you still get the same answer as 51,194. Okay, so that will be the value of the diameter of Uranus. So Roman figure 3, the ratio of diameter of Neptune, so you can say n for Neptune, ratio diameter of Saturn, you can say s, can be written in the form 1 to n. You have 1 to n. So find the value of n. So we need to get the diameter of these two, that is for Neptune and then Saturn respectively. So let's scroll up. For Neptune, the diameter of Neptune is 49,500 and that of Saturn is 120,500. So we can now put it there respectively. So I think it's better to remove this first. So let's put their corresponding diameters there. So we have 49500 and we have 120,000 respectively. So if we want to have 1 ratio n, so that means we need to divide this by 49500. We divide these two by 49500. So that will give us 1 into 2.43. So in form of 1 ratio n, now if you compare this 1 ratio 2.43 with 1 ratio n, so you see that n is equals to 2.43. Okay, so Roman figure 4, find the average distance of Neptune from the Sun as a percentage of average distance of the Earth from the Sun. So in this case, so we'll say the average distance of Neptune, that is 4.495 if you check the table. Okay, that's times 10 to the power of 9, then divided by the average distance of the Earth is 1.496 times 10 to the power of 8. Okay, so this times 100%. So these are standard form numbers. So we can divide 4.495 by 1.496, then times, this will be 10 to the power of division of indices, 9 minus 1, then times 10 to the power of 2 for the percentage. So if you do this, if you divide 4.495 by 1.496, so you will get 3.00468, then times 10 to the power of 1 for this, and times 10 to the power of 2 for this. So we can actually combine these two together. So we are going to have 3.00468 times 10 to the power of 1 add 2, that is multiplication of indices, that will be 3. So the final answer will be 3.004 468 times 10 to the power of 3. So that is what you have there. So let's go to the next question. Roman figure 5. Distances within the solar system are also measured in astronomical units AU. The average distance of Jupiter from the Sun is 5.20 AU. Calculate the average distance of Mars from the Sun in astronomical units. We know that the distance of Jupiter in kilometers is given as 7.786 times 10 to the power of 8 kilometers. So, and the corresponding average distance of Jupiter in astronomical units is given as 5.20. And for Mars, we know that the distance in kilometer is 2.279 times 10 to the power of 8 kilometers, and the corresponding value of it in astronomical units will be x. So if you cross multiply, so you multiply this by this and divide the result by this, that will give you your answer. So that will be 2.279 times 10 to the power of 8 multiplied by 5.20, then divided by 7.786 times 10 to the power of 8. Okay, so this will give you 1.52. So this will give you 1.52. Alternatively, you can firstly calculate the corresponding value of 1 kilometers in astronomical units. So by saying 7.786 times 10 to the power of 8 kilometers is giving us 5.20 astronomical units. Okay, so 1 kilometer will now be equal to what astronomical units? So if you do this, you get the value of x to be equals to 6.68 times 10 to the power of -9. So that means 1 kilometer is equals to 6.68 times 10 to the power of -9. So from here, you can now calculate the astronomical value of the mass. Okay, so by saying by using this relationship, okay, so if 1 kilometer is equals to 6.68 times 10 to the power of -9 astronomical units, then what will be the value of what? 2.27 times 10 to the power of 8 kilometers in astronomical units. You just multiply them and you still get 1.52. So let's go to the next one. That is Roman figure 6. The diameter of Mars is 39.2% greater than the diameter of Mercury. So calculate the diameter of Mercury. So from the question, it is clear that the diameter of Mars is 39.2% greater than the diameter of Mercury. So if you go to the table, you see that the diameter of Mars is 6,800. So that means, so we can say that at 100%, the diameter of Mars is equals to 6,800 kilometers. Okay, so if the diameter of Mars is now 39.2% greater than that of Mercury, so that means we need to find the diameter of this Mars when it is 39.2% smaller. So that will be 100% minus 39.2%. So that will be 60.8% will be equals to x. So this will be the value of the diameter of Mercury. So if you cross multiply, so that means you're going to have the value of x to be equals to 6800 multiplied by 60.8, everything divided by 100. So if you do this, you get the value of x to be equals to 4134.4. So that will be the diameter of Mercury. So let's go to part B. 1 night year is the distance that light travels in a year of 365.25 days. The speed of light is 2.9979 times 10 to the power of 5 kilometers per second. Show that 1 light year is 9.461 times 10 to the power of 12 kilometers. Correct to 4 significant figures. Okay, we know that speed is equals to distance over time. Then we can now key in the values there. So the speed is equals to 2.9979 times 10 to the power of 5. That's the speed. Then equals to, we want to find the distance. Then over the time. The speed is in kilometers per second. So the time should be in seconds as well. But we have it currently in days. That is 365.25 days. So we're going to have 365.25. This is in days. If you multiply by 24, it will be in hours. If you multiply by 60, it will be in minutes. Then you multiply by 60 again, then it will be in seconds. So this is what we need to do. Then finally you need to cross multiply. So distance therefore will be equals to the product of 2.9979 times 10 to the power of 5 and 365.25 then times 24 times 60 times 60. So this will be your answer. So if you do this, you have 2.9979 times 10 to the power of 5 multiplied by the product of these numbers will give you 3.15576 times 10 to the power of 7. So now you need to multiply the standard form numbers. So that will be 2.9979 multiplied by 3.5576. So, and when you correct the answer to 4 significant figures, you get 9.461. Then we are left with times 10 to the power of 5 times 10 to the power of 7. So this will give you 9.461 times 10 to the power of 5 add 7. That is multiplication law. So that will be 12. So we are able to get this. So let's go to B Roman figure 2. The distance from the Andromeda galaxy to Earth is 2.40 times 10 to the power of 19 kilometers. Calculate the time taken for the light to travel from this galaxy to Earth. Give your answer in millions of years. So what you need to do is to get the time, and we know that the time is giving us distance over speed. So the distance is 2.40 times 10 to the power of 19 kilometers. So divided by the speed. Already we know that the speed is 2.9979 times 10 to the power of 5 kilometers per second. Okay, so and we are to leave our answer in millions of years. Okay, so from here we have 2.40 divided by 2.9979. So times 10 to the power of 19 minus 5. That's division of indices. And if you divide 2.40 by 2.9979, so you will get 8.0056 times 10 to the power of negative 1, because this one will give you 0.800056. So you have to write it in standard form, and it will be negative 1. Then times 10 to the power of 19 subtract 5, that will be 14. Okay, so we cannot apply multiplication of indices here. So finally you will get 8.0056 times 10 to the power of minus 1 plus 14, that will be 13. Okay, so this will be the time in seconds. Now we need to convert these to years. So to do that, so you firstly divide by 60, that will be in minutes. So if you divide by another 60, it will be in hour. So if you divide by 24, that will not be a day. Then if you multiply by 365, then that will be a year. So from here we have 8.0056 times 10 to the power of 13. So divided by, so if you multiply 60 by 24 by 365, so you get 3.1536 times 10 to the power of 7. So from here, if you divide 8.0056 by 3.1536, so you will get 2.54. Then multiply by 10 to the power of 13 divided by 10 to the power of 7, that is division of indices. That will be 10 to the power of 13 minus 7, and you get 6. So this will be the final answer. And if you want to write it in ordinary form, so this will be 254, then 0 0 0 0. So that is 1 2 3, command here, 1 2 3, command here. So that means you have 2,540,000 years. So that is what we're going to have here. So you can write it in standard form as 2.54 times 10 to the power of 6, or you write it as 2,540,000 years. Okay, so that is what you have there. So let's go to the next question. That will be question 4. Lucia has two fair spinners. Spinner A is 5-sided and is numbered 1 2 3 4 5. Spinner B is 9-sided and is numbered 3 3 3 4 4 4 4 5 and 5. Lucia spins the two spinners and records whether they land on a prime number. So Roman figure 1, complete the tree diagram. So if the probability of prime is 3 out of 5, so probability that it is not prime will be 1 minus 3 out of 5, and that will give you 2 out of 5. Okay, that's for spinner A. So for spinner B, the probability that it is prime will be the number of prime numbers there over total, that will be 5 out of 9. Okay, and the probability that it is not prime, it will be 4 out of 9. Of course, this is an independent event, so we still have 5 out of 9 here, and we have 4 out of 9. So that is how to complete this. Okay, if it was to be a dependent event, okay, so then this will not be 5 out of 9. Okay, it will be based on the conditions, but since this is an independent event, so we maintain the probabilities as we have here and here. Okay, so let's go to Roman figure 2. Find the probability that the two numbers are both prime. Okay, so in this case it is prime here, 3 out of 5 and 5 out of 9. So we have 3 over 5 and 5 over 9, and means multiplication over 9 here. So this will be 15 out of 45. Or you can simplify this if you don't want to multiply straight away. 5 will cancel 5, 3 goes in 9, 3 times, so you have 1 out of 3, and better still, you can say 15 here 1, 15 in 45 3. So you have the probability to be 1 out of 3. The two numbers are not both prime. Here you can directly get it from the answer you have here. That will be 1 minus probability that they are both prime, that is 1 out of 3, and that will give you 2 out of 3, as we only have 2 events there. Alternatively, you can get it from the tree diagram. Okay, the first one will be this 3 out of 5, 3 out of 5 times, then the second one will be 4 out of 9. Okay, so this is one way, or which is addition. So the first one will be 2 out of 5, and the second one will be 5 out of 9. Okay, or that is addition. The third one will be 2 out of 5, okay, and 4 out of 9. Okay, so this is how you can get the answer from the tree diagram. You can see that in the 3 cases here, so none of the cases is as prime numbers to be the 2. Okay, so that is what you need to do. If you simplify this, we are going to get the same answer, which is 2 out of 3. So we have 2 out of 3 here. So the next question will be question 4b. Part B, Lucia spins spinner A 120 times. Find the expected number of times the spinner lands on a prime number. The probability that it lands on a prime number is 3 out of 5. Then multiply by the total number of trials, that is 120, and this will give us 72. So the expected number of times the spinner lands on a prime number is 72 times. So let's go to part C. Lucia spins spinner B twice. Find the probability that the two numbers it land on add up to 9 or more. So in this case, you have to construct a table. So it will be in form of this. So we are going to have something like this. Sum that will be greater than or equals to 9 will be the combination of 4 against this 5 here. So that means from here we are going to have 9 here. You have 9 here. So you have 9 here. 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 9. Then this will be 10. Then this will be 10. Okay. So you're going to have 10 here. 10 here. You're going to have 9 here. 9. Then you have 9, 9, 9, 9, and finally 9 and 9. So how many numbers do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 summations to be greater than or equals to 9. Out of the total will be 9 times 9, that is 81. Okay, let's go to part D. Lucia keeps spinning spinner B until it lands on a 4. Find an expression in terms of n for the probability that this happens on the nth spin. Okay, so some students are likely to make a mistake here because they can easily write 4 out of 9 then raised to the power of n. So this will be incorrect, as this will always give you as this tells us that for every spin, so it lands on 4. Okay, so all the trials lands on 4. Okay, so this will be incorrect. So let me give you an instance. So we already know that the probability that it lands on 4 is 4 out of 9, and the probability that it does not land on 4 will be 1 minus 4 out of 9. So that will be 5 out of 9. Okay, so let's take an example. Let's say he spins it 9 times, okay, and it lands on a 4 at the 9th one. So that means he was trying for the first 9, okay, and he was unsuccessful and successful at the 9th one, so that at the 10th one. So that means the previous 9 trials were unsuccessful. So that means we're going to have 5 out of 9 raised to the power of what? 10 minus 1. So that is for the 10 minus 1. So that is for the 9 trials that were unsuccessful. Then the 10th one that is now successful will be 4 out of 9, okay, to the power of what? 1. Okay, so you can see that we have the 10 trials. So to generalize it now, it will be 5 over 9 for the failure, okay, so it will be n minus 1 multiplied by 4 out of 9, okay, for the one that lands on a 4. So the formula will be 5 out of 9 to the power of n minus 1, then multiplied by 4 out of 9. So this will be the nth term, okay, for the probability that this happens on the nth spin. So for instance now, this one happens on the 10th spin, okay. So that is the example I cited here, okay. So that is how to get the answer. Now let's go to the next question. That will be question 5a. Question 5a. ACD is a right angled triangle. B is on AC and BC is equals to 54.5 meters. AD is equals to 83.2 meters and angle ABD is equals to 38 degrees. Calculate angle ACD. So we can mark angle ACD as X, okay. So what we need to do is to consider this triangle from triangle ABD, so we can have opposite, that is opposite over adjacent to find BA. So we can say from triangle ABD, so we can have tan 38 degrees to be equals to opposite, that is 83.2 meters over BA. We'll get BA to be equals to 83.2 divided by tan 38. If you input this into your calculator, so you get the value of BA to be equals to 106.5 meters. So that means the value of BA now is 106.5 meters. So equally from triangle ACD, so let's say from triangle ACD, that is from triangle ACD, that's the bigger triangle. So we can also have tan X to be equals to, so we have tan X to be equals to opposite, which is 83.2 over the adjacent now, which will be 54.5 plus 106.5. So we have 54.5 plus 106.5. So this will be equals to 83.2 divided by approximately 170. So that means tan X is equals to, if you divide 83.2 by 170, so you get 0.4894. If you take tan inverse of both sides, so X is equals to tan inverse of 0.4894, and that will give you 26.1 degrees. That will be the value of angle ACD. So part B, EFG is a right angle triangle. A circle can be drawn that passes through the three vertices of the triangle. On the diagram, mark the position of the center of the circle with a cross. Explain how you decide. Okay, so for you to mark this, you need to bisect two sides. So let's bisect two sides. So you can now mark point X here. You can cross this. This is where the two bisector meets. So that will be the center of the circle. So if you want to write now, so on the diagram, mark the position of the center of the circle with a cross. So the explanation is that by bisecting any two sides of the triangle. So that's what you do to get the center of the circle. So let's go to the next question. That will be question 6. Question 6a. Complete the table for the three sequences. We have sequences A, B, and C respectively. For sequence A, the term to term rule is add 4. So we're going to have 5 plus 4, and that will be 9 here. For sequence B, this is a quadratic sequence because we get common difference at the second difference. So let's write it here: 7, 13, 23, and 37. So if you do 13 subtract 7, that will give you 6. Then 23 minus 13, that will give you 10. So if you do 37 minus 23, that will give you 14. So you can see that at the first difference, we don't have common difference. So if you do the second difference, you'll see that we have 10 minus 6, that will give us 4. 14 minus 10, that will give us 4. So at the second difference, we have common difference. So that means this is a quadratic sequence. So to get the next term, so you just have to add 4 to 14, then to 37. That is 4 plus 14 plus 37 will give you the next term. That will be 55. If you look at the chain, so 4 plus 6 plus 13 will give you 23. And 4 plus 10 plus 23 will give you 37. So that means 4 plus 14 plus 37 will give you 55. So that is how you get the next term. Okay, so for sequence C, we have 2 out of 27, 3 out of 81, 4 out of 243, 5 out of 729. So this will be 6 out of, so the next power of 3 will be 2187, because the 27 is 3 to the power of 3, this is 3 to the power of 4, this is 3 to the power of 5, this is 3 to the power of 6, and this will be 3 to the power of 7. Now we are left with the n terms. So to calculate the n terms, let's start with sequence A. So let's write out the sequence. We have minus 7, minus 3, 1, and 5. Okay, so the common difference is 4. So we can say the n term is equals to 4n. So let's try this. So when n is 1, we have 4 times 1, you have 4 here. When n is 2, you have 8. When n is 3, you have 12. When n is 4, you have 16. You can see that our new sequence is not the same as the given sequence. So that means 4n is not enough to be the n term of this sequence. So what we need to do is, what are we going to add to each of these terms here so that we have the terms here. So if you say 4 plus negative 11, you will get minus 7. 8 plus negative 11, you get minus 3. So that means the n term will be 4n minus 11. So let's test for 1. 4 times 1, 4. 4 minus 11, you have minus 7. So that means the nth term of sequence A will be 4n minus 1. So for sequence B, we've already confirmed that this is a quadratic sequence. So for a quadratic sequence, so what you need to do is to divide the common difference by 2 and multiply by n squared. So that means we're going to have 2n squared. So let's form a new sequence with this one. So this will be 1 times 1, 1, 1 times 2. So you're going to have 2. So the next one will be 8. The next one will be 18. The next one will be 32. So let's write the given sequence up here. That will be 7, 13, 23, and 37. So we need to subtract this. So that will be 7 minus 2. That will be 5. 13 minus 8 is 5. 23 minus 18 is also 5. 37 minus 32 is equals to 5. So since we have common difference now, so that means the nth term will be 2n squared plus this constant, which is 5. Okay, so at it being after the subtraction, we have a linear sequence. Then we have to follow the steps here to get the nth term, and we add the two results together. But since we got a constant, so that means the nth term of the quadratic sequence is 2n squared plus 5. So 2n squared plus 5. So the nth term of sequence C, so let's scroll down a little bit. So if you observe very well, the denominator is a power of 3. So we can rewrite it in form of base 3. So that means we are going to have 2 over 27 is 3 to the power of 3. Then 3 over 81 is 3 to the power of 4. 4 over 243 is 3 to the power of 5. Then 5 over 729 is 3 to the power of 6, and so on and so forth. Okay, so that implies that there should be 1 before this. So when n is 1, then the denominator will be 3 to the power of 2, as this will make it easy for us to get the nth term. From what you have here, you see that when n is equals to 1, so the denominator is 3 to the power of n plus 1. Okay, so that means we can have n here, then over 3 to the power of n plus 1. So when n is 1, for instance, we're going to have 1 at the numerator, then we have 1 plus 1, that is 3 to the power of 2, which will give us this. So when n is equals to 2, we're going to have 2 at the numerator, and the denominator will be 3 to the power of 2 plus 1, that will be 3. So that means the nth term here is n over 3 to the power of n plus 1. So that is how you can complete that. Let's go to the next question. In a sequence, the sum of the first 49 terms is 7,644. The sum of the first 50 terms is 7,975. Find the 50th term of this sequence. So the 50th term will be sum of the first 50 terms minus sum of the first 49 terms. So that will be 7,975 minus 7,644. This will give us 331. So the 50th term is 331. So let's go to the next question. Question 7. The frequency table shows the time of each of 42 athletes in a race. Calculate an estimate of the mean. So here we need to have 2 columns. So the first one will be for the average of the time, that is the class intervals. So we'll call that x. Then we'll get the product of this and this number of athletes, so that is f. So that is, we'll get the product of f and x, so that will be another column. So to do this, you can, so let's get the values of the column x. So to get the values of column x, you have to come to the first column here. You add 216 to 219 and divide by 2, and you do the same thing for all the rows. So you're going to get this 217.5. So 221.5. So you have 229, you have 239, and you have 254. So next we multiply column f by column x. So that will be 9 times 217.5. So that will give us 1957.5. Okay. Then the next one will be 3101. Next one will be 3206. Then 478762. So the summation of the last column will be 9504.5. And already we know that we have 42 athletes, so summation f will be 42. Then we cannot calculate an estimate of the mean. So an estimate of the mean x bar is equals to 9504.5 divided by 42, and that is approximately 226. So you have 226 here. So part B, complete the histogram to show the information in the frequency table. 2 of the blocks have been drawn for you. Okay, since we don't have equal intervals in each of the class intervals, so we need to find the frequency density. So the frequency density is given as frequency over the class size. So if you scroll up, you can add another column here. Let's say FD for frequency density. Okay, so the first one will be 9 divided by the class interval, class size, that is 3. So 217, 218, and 219. So the class size here is 3. So 9 divided by 3 will be 3. So the class size for this next row is 5. So 14 divided by 5, you get 2.8. So the next one, the class size is 10. So 14 divided by 10, 1.4. So the next one, the class size is also 10. So if you do 2 divided by 10, you have 0.2. And the last one, the class size is 20. So if you divide 3 by 20, you have 0.15. So this is what you need to complete the histogram. Okay, so if you scroll down, you see that when the frequency density is 3, the class size is between 216 and 219. So that has been drawn for us. And the last one, when the frequency density is 0.15, the class size is 244, is between 244 and 264. It has also been drawn for us. So we are left with our frequency density of 2.8, 1.4, and 0.2 with their corresponding class intervals. Okay, so I'll do that and show you the results. So I have completed the histogram. So you can see this one, when it is 2.8, so the class interval is between 219 and then 224, and when the frequency density is 1.4, the class interval is between 224 and 234 here for this one, and the last one is when the frequency density is 0.2, so the class interval is between 234 and 244. So let's go to the next question. Question 8. The diagram shows a solid formed by joining two hemispheres and a cylinder. The radius of the large hemisphere is 5.4 centimeters. The radius of the small hemisphere and the radius of the cylinder are both 3.6 centimeters. The height of the cylinder is 6.5 centimeters. So show that the volume of the solid is 692 centimeter cube. Correct to the nearest cubic centimeter. Okay, so the volume of a sphere is with radius r is giving us 4/3 pi r cube. Okay, so from here we know that this will be the height of the cylinder, and the radius of the small hemisphere is 3.6, so the radius of the cylinder is also 3.6 centimeters. Okay, so from this we want to calculate the volume of the solid. So the volume of the solid, let's say let's denote it by this sign. This is the volume of the solid, will be equals to volume of the small hemisphere plus volume of the cylinder, okay, then plus volume of the big hemisphere. Okay, so let's use this. Okay, the volume of the solid is equals to volume of the small hemisphere plus volume of the cylinder plus volume of the big hemisphere. Okay, so that will be equals to the volume of the small hemisphere will be 2/3. Okay, because the volume of a sphere is 4/3 times pi r cube. So to get the volume of a hemisphere, you multiply by 1/2. Okay, so 2 here 1, 2 here 3. So that means the volume of the small hemisphere will be 2/3 pi r cube plus the volume of a cylinder is pi r square multiplied by h plus the volume of the big hemisphere will also be 2/3, then pi r cube. So let's key in the values. So this will give us 2/3 times 3.14 times 3.6 cube plus 3.14 times the radius of the cylinder is also 3.6 squared times the height. So the height of the cylinder is 6.5 times 6.5, then plus 2/3 times 3.14 times the radius of the big hemisphere is 5.4 cube. So if you do this, okay, you get 97.7. So plus, if you do this, you get 264.5. Okay, and if you do this, you are going to get 329.6. So if you add the three together, you will get 691.8 centimeter cube. So when correct to the nearest cubic centimeter, so this will be approximately 692 centimeter cube, okay, as required. So we have shown that the volume of the cylinder is equals to 692 centimeter cube. Okay, so Roman figure 2, a mathematically similar solid is made of silver. In this solid, the cylinder has radius 0.6 centimeter. 1 centimeter cube of silver has a mass of 10.49 grams. Calculate the total mass of this silver solid. Once we get the volume of the silver solid, then we'll multiply it by 10.49 grams. That will give us the total mass of the silver solid. So how do we get the volume of the silver solid? Radius of the cylinder of the silver solid, so let's denote that by RSS to be equals to 0.6 centimeters. So this is the radius of the cylinder of the silver solid. So whereas we know that the radius of the cylinder of the initial solid is equals to 3.6 centimeters. Okay, and we know that the volume of the solid, that is Vs, is equals to 692 centimeter cube. So we can get the volume of the silver solid, that's VSS. So this is what we want to get. Okay, so by using this convention, Vs over VSS, that is the volume of the solid over the volume of the silver solid, will be equals to the cube of the radius of the cylinder of the solid, then over, so RSS cube, that is the cube of the radius of the cylinder of the silver solid. So we can use this to get the answer since they are similar. It's just the normal formula we know. The volume is equals to cube of the scale factor, length of the scale factor. So that is what I did there. So we can now key in the values. We have 692 over VSS to be equals to 3.6 cube over 0.6 cube. Okay, so if you cross multiply, you will get VSS to be equals to 692 times 0.6 cube over 3.6 cube. If you input this into your calculator, then you will get VSS to be equals to 3.20. So that is the volume of the silver solid equals to 3.20 centimeter cube, right? So we can now get the total mass of this silver solid. Already we know that 1 centimeter cube is equals to 10.49 grams. Then 3.20 centimeter cube equals to x. So if you cross multiply, so x will be equals to 3.20 centimeter cube multiplied by 10.49. So this x will be equals to 36. X will be equals to 33.6 grams. So that will be the total mass of the silver solid. So we have it to be 33.6 grams. So let's go to the next part, that is part B. AOB is a sector of a circle, center O. AO is 10 centimeters and the sector angle is 216 degrees. Calculate the length of the arc of this sector. Give your answer as a multiple of pi. Okay, so the length of an arc is given as theta over 360 times 2 pi r. That's the length L of this arc. Okay, so if you key in the values, so we are going to have the length to be equals to 216 degrees over 360 degrees, then multiply by 2 times pi times the radius. The radius is 10. So if you do that, L will be equals to if you divide 216, okay, let's have 216 over 360, then multiply by 20 pi. So 0 cancel 0, so you can say 36 here once, and can say 36 in 216, that will be 6 times. So if you multiply 6 by 2, that will be 12. So we are going to have 12 pi. Hence, the length of the arc is 12 pi centimeters. So we have 12 pi centimeters. So that is the length of the arc as a multiple of pi. So let's go to Roman figure 2. A cone is made from this sector by joining OA to OB. So if we join OA to OB, so this is what we're going to have. So we have point O to be here, and A and B will be this side. Okay, so here will be the center of the circle here, and the radius will be R, which we don't know, and this will be the height of the cone, which is H. So the radius of the arc will turn to the length, the slant height of the cone. So that is, this will be 10 centimeters now. Okay, so we need to get the values of R and H before we can calculate the volume of this cone. Okay, so the volume of a cone is already giving us 1 out of 3 pi R square H. That is 1/3 of volume of a cylinder. That is the volume of a cone. So we need to get R and H. So how do we go about it? Okay, it's very simple. You see that the length of the arc, okay, the length of the arc is now the circular base of this cone. Okay, so the length of the arc, let me do something like this. The length of the arc is now the circular base of this. The length of the arc is now the circumference of this circular base of this cone. So that means you can say the length of the arc, that is theta over 360 times 2 pi R, 2 pi R, let's use capital R, then that's the length of an arc, is now equals to circumference of this circle. That will be 2 pi small letter R, because the radius of this circle is R here. So now we know that 2 pi can cancel 2 pi, so we are left with R to be equals to theta over 360 times capital R. So we can key in the values here and we'll get the value of the radius. So R will be equals to 216 divided by 360 times 10. So 0 cancel 0 here, 36 here, 1, 36 in 216, that will be 6 times. So that means the radius is 6 centimeters. Fine. Okay, so I can easily get the height now. So let's draw out this right angle triangle here. So we have something like this now. Okay, so we have something like this now. So this is point O. So this is AB. Okay, so the slant height is 10 centimeters. The radius is 6 centimeters. So we can use Pythagoras theorem to get the height. Okay, so the height will be H squared equals to 10 squared minus 6 squared. That will be H squared equals to 100 minus 36. That will be H squared equals to 64, and that implies that H equals to 8 centimeters. So that is the height of the cone. So we can now key in the values here. So the volume of the cone is now 1 out of 3 times pi 3.14 times radius squared. That will be 6 squared, that is 36, times the height. The height is 8. So if you do this, we are going to get 301 centimeter cube. So the volume equals to approximately 301 centimeter cube. So 301 centimeter cube. So that is the volume of the cone. So let's go to the next question. So that will be question 9. Question 9. F of x equals to 3x plus 1 into x plus 5 into x minus 4, and g of x equals to 2x minus 3. H of x equals to 4 to the power of 2x minus 1. Find f of 0. So since we know that f of x equals to 3x plus 1 into x plus 5 into x minus 4. So let's pass x equals to 0. So we're going to have 0 plus 1 into 0 plus 5 into 0 minus 4. So we are left with 1 times 5 times negative 4. So this is negative 20. So Roman figure 2, we have to find inverse of g of x. So we already know that g of x is equals to g of x is equals to 2x minus 3. So let's replace g of x with y. So that means we have y equals to 2x minus 3. Let's make x the subject of the formula. So if you do that, we're going to get y minus y plus 3, everything divided by 2 to be equals to x. So we have made x the subject of the formula. Then the next thing we need to do is to replace y with x and x with g inverse of x. So that means we're going to have x plus 3 over 2 to be equals to g inverse of x. Okay, so that is what we're going to get here. So the inverse is x plus 3 over 2. So Roman figure 3, gh of 2. So to get gh of 2, you need to firstly get h of x. Okay, so we already know that, okay, g of x equals to 2x minus 3, and then g of h is giving us 4 to the power of 2x minus 1. G of h is giving us 4 to the power of, so g h of x is giving us 4 to the power of 2x minus 1. So we can easily get g into h of x. Okay, so what we need to do is that in g of x, anywhere we see x, we key in h of x there. So that means we're going to have 2 into bracket. Now let's put h of x, which is 4 to the power of 2x minus 1, close the bracket, then minus 3. So this is our gh of x now. So that will be equals to, if we simplify this, so we have 2. 4 is the same thing as 2 to the power of 2, then into bracket 2x. Okay, let's write this for you to understand it better. Okay, so gh of x is now equals to 2. Then what we have inside the bracket, I can write it in base 2. It will be 2 to the power of 2, that is 4. Then into bracket 2x minus 1, then bracket close, then minus 3. So this will be 2 to the power of 2 into bracket. So this will be 2 into bracket 2 to the power of 2 times 2x, 4x minus 2 times 1, 2, bracket close, minus 3. So we can apply multiplication of indices here. So we are going to have 2. Okay, let's write here. We're going to have 2 into 1 plus 4x minus 2, then minus 3. That is gh of x. So if we simplify further, we have 2 to the power of 4x minus 1, then minus 3. So now if we pass, we cannot get gh of 2 now. So gh of 2 will now be anywhere we see x, we put 2 there, because this is currently gh of x. Okay, so that will be 2 to the power of 4 into 2, then minus 1, then minus 3. So 4 into 2, that is 8. 8 minus 1, that is 7. So we have 2 to the power of 7, subtract 3. 2 to the power of 7, that is 128, subtract 3, that will be 125. So gh of 2 is 125. So let's go to part B. So g of 2x equals to 7. find the value of x. So we already know that g of x is equals to 2x minus 3. So let's check that again. 2x minus 3, yes, so that's correct. So we can now get g of 2x now. So that is, anywhere we see x, we substitute 2x. So we have 2 into 2x, then minus 3. Let's expand the bracket. We have 4x minus 3. But this is equals to 7. So we quote it to 7. Then we collect like times. We have 7 add 3 to be equals to 4x. 10 is equals to 4x. And x is equals to 10 over 4. X equals to 5 over 2. X equals to 2.5. So the value of x equals to 2.5. So part C, simplify gs squared plus gg of x plus 1. So the first thing we need to do is to find x squared. So also we know that g of x is equals to 2x minus 3. So we can get g of x squared, that is, anywhere we see x in g of x, we replace it with x squared. It will be 2 into x squared minus 3. So we are done with this. So next is to find gg of x. Okay, so g into g of x, that is gg of x. So it will be equals to anywhere we see x, we pass in g of x. So we are passing itself into x. So we have 2 into, then let's pass in g of x. G of x equals to 2x minus 3. Okay, then minus 3. So I have passed g of x into x. So this will now be, let's expand the bracket, 4x minus 6 minus 3. That will be equals to 4x minus 6 minus 3. That will be minus 9. So this is g of x. So we can now substitute this. So this is the second one now. So we can substitute these two into this expression here. That is g of x squared plus gg of x plus 1. That will be equals to 2x squared minus 3. Add 4x minus 9, then plus 1. So that will give us 2x squared minus 3 minus, okay, let's put down plus 4x, then minus 3 minus 9, that will be minus 12, minus 12 plus 1, that will be minus 11. So this we can simplify this to 2x squared plus 4x minus 11. So let's go to the next question. That will be part D. So let's go to the next question. That will be let's go to the next question. That will be part D. Find h inverse of 16. So before you can get h inverse of 16, you need to firstly get h inverse of x. So starting from h of x is giving us 4 to the power of 2x minus 1. That is h of x. So let's replace h of x with y. So we can say we have y to be equals to 4 to the power of 2x minus 1. So now we need to make x the subject of the formula. To do this, we need to take logarithm of both sides. So that will be log y to be equals to logarithm of 4 to the power of 2x minus 1. Then we can write this as log y to be equals to 2x minus 1. Then log 4. So from here now we can separate. Okay, there's bracket here. So let's divide both sides by log 4. So if you do that, we're going to have log y over log 4 to be equals to 2x minus 1. Then we need to collect like times. So let's send minus 1 to the left hand side. So we're going to have log y over log 4 minus plus 1 equals to 2x. So finally we can divide both sides by 2, or you can easily multiply both sides by a half. So that will leave us with log y over log 4 plus 1, okay, into 1 over 2 equals to x. Okay, so now let's replace y with x and x with h inverse of x. So that means we're going to have log x over log 4 plus 1, okay, into brackets 1 over 2, then equals to h inverse of x. Now that we have found h inverse of x, it is easy to find h inverse of 16. So what we need to do is just to pass in 16. So I can say h inverse of 16 will be equals to log 16 over log 4 plus 1, everything multiplied by a half. So log 16 divided by log 4, that will give you 2. Okay, so that will give you 2. Then so if you use your calculator and divide log 16 by log 4, you will get 2. Ordinarily there is no space here. I would have shown you how to do that. Okay, let me just do it here. So you can write log 16 as 2 to the power of 4 over log 4 as 2 to the power of 2. So we same thing as 4 log 2 over 2 log 2. Okay, so log 2 cancel log 2. 4 divided by 2 is 2. So that is how we get 2. Okay, so this one is 2. Okay, then plus 1. Okay, multiplied by a half. So 2 plus 1, 3 times 1 over 2. So the answer will be 1 whole 1 out of 2. So let's go to the next part. Okay, so f of x equals to this. So this can be written in the form f of x equals to as cubed plus bs squared plus cs plus d. Okay, so what you need to do is to expand this by multiplying this by this. Then the answer you get there, you multiply it by this. So if you expand that, we're going to get f of x to be equals to 3x cubed, then plus 14x squared, then minus 59x, then minus 20. So if you compare this with f of x to be equals to ax cubed plus bx squared, then plus cx plus d. So you see that a is equals to 3, b is equals to 14, then c is equals to minus 59, and d is equals to minus 20. So we can put the values here. A is equals to 3, b is equals to 14, c is equals to minus 59, and d is equals to minus 20. Okay, so let's go to the next question. That will be question 10. Question 10a. ABC is a triangle. B is the point 1, -10. A is the point 4, 14, and CA is equals to -11 and 8. Then find the coordinates of C. So what we need to do is to have the rough sketch of the triangle. So if you draw the triangle up here, then you have this to be here and this to be here. So you have point A to be here with coordinates 4, 14, then B with coordinates 1, -10. Then we have point C to be here with coordinates x, comma, y. So we can write this in component form. So that will be 4 minus 1. That will be 3i plus 14 minus 10. That will be plus 24j. Then for this side is already given as minus 11 and 8 respectively. So we're going to have minus 11i then plus 8j. So for this one here, we are going to have 1 minus x into I, then plus minus 10 minus y, minus 10 minus y into j. So that is what we are going to have here. So in this context now, we can say that CA is equals to CB plus BA. So with the arrows on top, then we can there say that 1 minus x into I, then so we can say minus 11i plus 8j is equals to, then we have 1 minus x into I, then plus open bracket minus 10 minus y into j, then plus 3i plus 24j. So you need to open the brackets and then collect like times. So you need to collect like times here. So we're going to have minus 11i plus 8j to be at the left hand side equals to, then you have 1 minus x then plus 3 into I, 1 minus x plus 3 into I, because they are like times. Then you have plus open brackets minus 10 minus y, then plus 24 into j. So this will give us minus 11i plus 8j to be equals to, this will give us 4 minus x into j. So that is what you have here. So plus this will give us 14 minus y into j if you simplify that. So by equality of vectors, so the left hand side is equals to the right hand side, so we can do comparison. So that means we can say 4 minus x is equals to negative 11. So 4 minus x equals to negative 11. So that means 4 plus 11 is equals to x. That means x is equals to 15. So I can put 15 there. Okay, so this implies that x equals to 15. Also, we can say that 14 minus y equals to 8. That is this one. 14 minus y is equals to 8. 14 minus y is equals to 8. So that means 14 minus 8 equals to y. Then you can say 6 is equals to y. So that means y is equals to 6. So the coordinates of point C will be equals to 15, 6. So Roman figure 2, find BA. So BA is already here. That is 3i plus 24j. So which I can write as 3 then 24 here. And Roman figure 3, we are asked to find the magnitude of CA. So don't forget that CA is the same as minus 11i plus 8j. So we can say the magnitude of CA will be equals to square root of minus 11. Sorry, let me write this again. And say minus 11 squared plus 6. So we have minus 11 squared plus 8 squared. So everything under the square roots. So the magnitude of CA is equals to square root of minus 11 squared plus 8 squared. So this will be equals to square root of 121 plus 64. This will be equals to square root of 185, and that will be equals to 13.6. So we have 13.6. So let's go to the next question. Question 10b. OMN is a triangle. OM equals to A and ON equals to B. R is a point on MN such that MR ratio RN equals to 3:2. ORT is a straight line. Show that OR equals to 2/5A plus 3/5B. Okay, so we know that OR from the triangle OR is equals to ON plus NR. So you move from O to N, then from N to R. So we already know that ON equals to B. So we need to calculate NR. So to do that, we need to use find MN first. Okay. So MN will be equals to MO plus ON. Okay, and that will be equals to minus A, as we don't have MO, we only have OM. So minus A plus B, which could be written as B minus A. So this is MN. Okay, so we can now find the ratio of so we can now find Rn using the given ratio. So Rn in this case will be equals to 2/5 into brackets B minus A, because Rn equals to 2/5 of Mn, and Mn is already B minus A. So this is the value of our Rn. So we can open the bracket. This will be 2/5B, then minus 2/5A. So we can now substitute the value of Rn into the first line as so we can now substitute the value of Rn into the first line, that is here. So we have OR now to be equals to ON, that is B, then plus NR. So NR will be, so we can substitute Rn into, now we can substitute the value of Rn into the first line, that is here. So we know that OR is equals to ON plus NR. So ON is B, then plus NR. So we don't have NR here, we have Rn. So it will be minus into bracket 2B, 2/5B, then minus 2/5A. So if you simplify that, we're going to get OR to be equals to B, then this will be minus 2B, minus 2/5B, minus 2/5B, then plus 2/5A. So if you simplify this, we are going to get B minus 2/5B. So that will be 3/5B, then plus 2/5A. So if we rearrange, so we will get 2/5A plus 3 over 5b. Okay, so that has been shown. So Roman figure 2, nt is equals to 4a plus kb, and ot equals to c of or. Find the value of k and the value of c. Okay, so we already know that mn equals to b minus a. So or is equals to 2 over 5a, then plus 3 over 5b. So that was given. So nt is equals to 4a plus kb. So that was given as well. But we know that ot is equals to on. Okay, so plus nt, like this. So we can now key in the value so that ot will be equals to b plus 4a, then plus kb. So let's call this one equation 1. So let's call this one equation 1. Okay, so but we also know that ot is equals to cor. Okay, so this was given as well. So we can say that ot is equals to c into bracket or is equals to 2 over 5, then 2 over 5a plus 3 over 5b. Okay, so we can call this equation 2. So we have ot to be equals to this in equation 1 and ot to be equals to this in equation 2. That means we can equate equations 1 and 2. That means it will be b. From equation 1, we have b plus 4a plus kb to be equals to, let's expand this bracket, we're going to have 2c over 5a, then plus 3c over 5, then b. Okay, so here we can combine kb and then b. So that will be 4a, okay, let's rearrange first, plus b plus kb, so to be equals to 2c over 5a, then plus 3c over 5b. Okay, so we can factor out b here, so we have 4a plus b into 1 plus k, then is equals to 2c over 5a, then plus 3c over 5b. So these two vectors are equal. So from here we can say that 4 is equals to 2c over 5. So which implies that 2c is equals to 4 times 5, 20. So that implies that c is equals to 10. So c is equals to 10. So also we can, I just compared this and this here. Okay, so we can also compare b into 1 plus k, b into 1 plus k, and then 3c over 5 into b. So you will see that oh, I should have written this as 1 plus k into b. The b should be here, but it's still okay. So this will be 3c So this will be 3c over 5, okay, so to be equals to k plus 1, okay, as they are equal. So in this case, we know that the value of c is equals to 10, so we can key in the value of c here. So this will be 3 times c, that is 3 times 10. We have 30 over 5 equals to k plus 1. So if you do this, 5 here, 1, 5 in 30, 6. So we have 6 equals to k plus 1, that implies that k is equals to 6 minus 1, and that will be 5. So the value of k is equals to 5 and the value of c is equals to 10. So part B, we are asked to find mt. So mt will be mo plus on plus nt. Okay, so we are going to have mt to be equals to mo plus on, then plus nt. So that is what we're going to get there. And we already know that mo is equals to minus a, okay, plus on, this is n, on, okay, is equals to b, okay, plus nt is equals to 4a plus kb, and k is 5, so it will be 4a plus 5b, so 4a plus 5b. So if we rearrange 4a minus a, that will be 3a, then 5b plus b, that will be 6b. So we can factor out 3, that will be 3 into a plus 2b. So you can write your answer like this or like this. So I'll just leave it as 3a plus 6b. Question 11. Differentiate x cubed minus 4x squared minus 3x. So this will be 3x squared minus 8x minus 3. Okay, so this will be 3x squared minus 8x minus 3. So part B, a curve has equation y equals to x cubed minus 4x squared minus 3x. Work out the coordinates of the two stationary points. Show how you're working. So we have y to be equals to x cubed minus 4x squared minus 3x. Okay, so let's divide this into 2. So here the y dx is the same as the result we have here. So we can say the y dx is equals to 3x squared minus 8x minus 3. But our stationary point, the y dx equals to 0. That means we can set this to 0. So this will be 3x squared minus 8x minus 3 equals to 0. So we need to solve this quadratic equation. So that will be 3x squared minus 9x plus 1x minus 3 equals to 0. So this will give us 3x into brackets x minus 3 plus 1 into x minus 3 equals to 0. So this will give us 3x plus 1 into x minus 3 equals to 0. So 3x plus 1 equals to 0, or x minus 3 equals to 0. So from here, x equals to minus 1 over 3, or x equals to plus 3. Okay, so we need to get the corresponding values of y for these 2 points. Okay, when x equals to 3, so y will be equals to 3 cubed, that is, you substitute into the given equation, minus 4 into 3 squared, then minus 3 into 3. So this will be, if you do this, y will be equals to, okay, this will be equals to 27 minus 3 times 3, 9, 9 times minus 4, minus 36, then minus 9. So y is equals to minus 18. So that is when x equals to 3, y is equals to negative 18. So similarly, you can substitute for x equals to minus 1 over 3. So we have y to be equals to minus 1 out of 3, okay, then minus 4 into minus 1 out of 3 all squared, then minus 3 into minus 1 out of 3. So if we simplify this, we are going to get y to be equals to minus 1 over 27, then you get minus 4 over 9, then this will give you plus 1. So if you simplify these two, you are going to get 14 out of 27. So 14 out of 27. So when s equals to minus 1 out of 3, so y is equals to 14 out of 27. So that's so we have worked out the coordinates of the two stationary points. So let's go to the next question. So determine whether each stationary point is a maximum or a minimum. Determine whether each stationary point is a maximum or a minimum. Show all your working. So we need the second derivative. Okay, so the square y over the x squared will be equals to, so don't forget that the y, the x is equals to 3x squared, okay, minus 8x minus 3. So we'll continue from here. So this will give us 6x minus 8, okay. So that is the square y over the x squared, okay. So let's get the value of the square y, the x squared, when x equals to 3. That's for the first stationary point. So we're going to get the square y over the x squared to be equals to 6 into 3 minus 8, which is equals to 18 minus 8, which is equals to 10. So we can say that the square y, the x squared, is greater than 0, or we can say it is positive. So that means it was increasing. That is the meaning. It was increasing. So that's this positive sign means that it is increasing. So if it is increasing, so that means it was, so this is the stationary point. From the stationary point here, so it was increased. From the stationary point here, it is increasing. So that means it was decreasing before it got to the stationary point. So for this case, we're going to have minimum points. So we can say that at x equals to 3, the corresponding value of y minus 18. So at this point, we have minimum points. Okay. So let's show the working for the second one. So let's get the value of the square y, the x squared, when x equals to minus 1 out of 3. So we're going to have the square y over the x squared. So it will be equals to 6 into minus 1 out of 3, then minus 8, 3 here 1, 3 here 2. So this will be equals to minus 2 minus 8, which is equals to minus 10. So we can say that the square y, the x squared, is less than 0. So or it is negative. So this means that after the stationary point, it was so this means that after the stationary point, it is decreasing. That's the meaning of negative. Okay, sorry, this should be negative. Yeah, so it is decreasing. So that means before it got to the stationary point, it was increasing. So we have maximum point here from the shape here. So that means at x equals to minus 1 over 3, 14 out of 27. So at this point, we have maximum point. So it is maximum. So this is the end of the solution. So in the next video, I will do the solution to paper 2-1. Until then, have your finger crossed. Please don't forget to subscribe to my channel, hit the notification bell to receive notification anytime I upload a new video. Also comment, like and share this video.